Here, I'm going to draw what's going on here. This is the barrel, and then there's this spring inside, and then there's the bullet like this, or the BB, or whatever it is. Okay? Now, this BB, when it flies out this way, this right here is this distance of 0.15 meters. Okay, and during this time, like when, does it make sense to you that that is the force diagram? Diagram makes sense to you.
Why is there friction?
Because we're told that there's friction in the barrel,
Oh.
and then friction would resist the direction of motion, right? Okay, so this one was energy. What is this one? Okay, you see that I drew these forces there to see if I could steer some of you away, and clearly it worked. We're looking for, or what are we looking for in this problem? Thing right here, velocity. So we have two pictures of this, here and here. When we had two pictures before, what were we supposed to do? What's that? Yeah, so we're looking at how this thing changed. And what do we use to analyze that? Momentum is just when you have collisions or when something blows apart, like when something separates. This is about energy. But now, instead of just MEI equals MEF, we have to add the work, the non-conservative work. And in this case, that work is done by friction. So what type of energy did it have right here? Yeah, PES. What type of energy does it have right here? Sorry, what?
The subscript after W, or?
Work, non-conservative work. It means it uses it up. So what type of energy does this projectile have when it comes out of the barrel? Kinetic. Is everyone clear on that? Okay, it's KE. That's the whole point of the gun, is to give the bullet kinetic energy, so it shoots and hits stuff. And then we have work done by friction. So this is 1/2 kx squared. That equals 1/2 mv squared plus. Now let's go over here and use this space. Work done by friction. What is work? FD. So if work is FD, then work done by friction is F sub FD. Does that make sense? Okay. No? Question? No? Yeah. Yeah, WF is always going to be F sub FD. It's the work done by friction. Yeah.
How did you know how to use 1/2 kx instead of the other?
Because what makes this thing move? What is that? What is this? Yeah, this is a spring. So what's making the ball move? The spring. That's why I use 1/2 kx squared. And then when it comes out here, how is it move? What's going on? It's moving. So what is the equation for F sub F? Yeah, it is mu F sub n times d. Take a look at that force diagram. F sub n equals what? Yeah, F sub n is going to equal to mg, right? So this becomes mu mg d. And we're looking for v. So I say mv squared over 2 is equal to kx squared over 2 minus mu mg d. And do you see what I can do here? Multiply both sides by 2 over m. Do you see why? This 2 cancels with this m cancels with that, and I get v squared by itself. And then when I multiply this out, I get kx squared over m minus 2 mu g d. And I can just take the square root of that. And this is going to give me my answer of 2.13 meters per second. Okay, so again, velocity is 2.13 meters per second coming out of the barrel. Right here is 1 meter. and then it's going to land x distance away from there. Does that make sense? Now let's take a look at this. Think about this for a second. I want to find x. I know Vx. Well, is there an equation that you have, the simplest equation that you have, that has x and v in it? What is that equation? Wow, is that the simplest equation you have that has x in it and v in it?
V squared equals V0 squared plus 2ax.
How about v is x over t?
Oh.
You guys are like way up here. I'm like down here in the muck, right? The simplest equation that you can think of. Okay, so do you see, what do we need? If we solve this for x, we say x is vt. What do we need to get x? We just need time. Now, let me ask you, if you know how high you are above the ground, can you calculate how long it'll take for you to hit the ground? How would you do it? No clue. At least you're honest. All right, let's take a look at this. We need the time, right? So we want time. What do we know about our fall? So vertical. Think vertical. What do we know? We know that y equals 1 meter. True? What else do we know? Think vertical. Very good. Acceleration is equal to 9.8 meters per second squared. Now, there's another one that's hidden. It's tough. Think vertical. What is the initial velocity? Yes, the initial vertical velocity is 0. Wait a minute, didn't you say the velocity was 2.13 meters per second? What am I talking about? Good. This is horizontal velocity. Vy is 0. Vy initial. Vy 0 is 0. That means initial. So we have y, a, v, and all we need is t. So I will use y equals v0t plus 1/2 at squared. That goes away. T is the square root of 2y over a. And that gives you 0.45 seconds. Now, can you calculate x? Yeah. Now it's a no-brainer. So do it. See what you get. Do it now. Oh, yeah. $4.96. Ta-da! Questions?